In this video, we are going to see another geometric sequences and geometric series. So before that, we have talked about the arithmetic sequences and the arithmetic series. They are for the linear relationship. It's keep adding the same number to get the next term. And from here, this is one example of geometric sequence. You will see you can find a pattern. So each term from the front term you times by the same number, then you will be able to get the next term. And this is we could use a exponential function to describe it, to model it. So keep adding the same number. That number is your base. So this number in geometric sequence, we call it common ratio or common multiplier, and in the exponential relation, that is just a base. That equals a base. And because this is ordered numbers, so the first term is 1. We don't start from the term 0. So when we write it as a general term or general formula, we use a times r to the exponent n minus 1. So a is the first term, is your y-intercept. If b greater than 1, then it will be increasing, and this is your y-intercept, that is your initial value. And r is same as our base for the exponential function. And because start from the first term, so it's not a 0 term, so we are going to use x equals n minus 1. So when n equals 1 is corresponding to our exponential function, x equals 0, initial term, okay? So that is x equals n minus 1, then other part is same as our exponential function. So t sub n is similar with y, but in the geometric sequence, we call it nth term. A is a first term, r is a common ratio, also is just a base. How to find this one? It could be found by dividing any term with a previous term, then you will have the common ratio or the base. And the application for that one is the base could be, if it's a exponential growth and the base is greater than 1, then we could write it as 1 plus the growth rate. So we could just add a percentage. So that is your exponential growth, and if it's less than 1, it's decay, it's 1 minus a percentage. So this is called decay rate. And the difference from the geometric sequence with exponential function is, in exponential function, x is continuous, and in the geometric sequence, the n value is discrete. All the countable numbers, term 1, term 2. So now we are going to see, same as before, how to determine the sum of terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 terms here. How to determine these 10 terms add together. So we don't want to use a calculator, then we want to see how we can find the sum easily. So from here we could see that the base of the ratio is 2 divided by 1 is 2. So we are going to times this ratio to this sum. Then we are going to have, if we write the sum equals this one, then ratio R2 times S will give us, this 1 times 2 give us 2, the next term. 2 times 2 give our 4. So you will see it's just times the previous term, then you will get the next term. Then the last term times 2 give you 1024. So we have this sum and the double of the sum. Then you will see if we subtract these two equations, so equation 2 subtract equation 1, we are able to cancel 9 terms out. So we are going to have 2s minus s equals 2 minus 2 cancel out. All the middle, these 9 terms cancel out. You will have -1 then plus 1023. So we collect the like terms. 2 minus 1 give you s equals, sorry, this is 1024. The I together will give us 1023. This is a sum. So you will see that it doesn't matter how many terms there. Always, if we times r with s, you will find out the first term and the last term times r will left. Then it will be equals rs minus s equals -a plus a times r to the exponent n. So by using this pattern, we are able to find the s. That is how we are going to find the sum. And the sum of this geometric sequence, we call it geometric series. So the sum of this one, we could write it as s. So s equals a plus ar plus ar squared plus until the last term. Then we want to cancel all the middle out, so we use r times s. Then you will find out a times r give you ar, and ar times r give you ar squared. Then continue. This second last term times r give you a r n minus 1. And the last term times r give you a times r to the exponent n, because multiplication is a degree 8. So n minus 1 times r to the exponent 1, n minus 1 plus 1 give you n. Then equation 1, equation 2, we are going to subtract. Equation 2 subtract equation 1, then we could cancel n minus 1 terms out. So we are going to have r times s minus s equals, this one 0 minus a give us -a, all the middle ar all cancel out, and the last term left. Then we collect the like terms. We are going to have r minus 1 times s equals a r to the exponent n minus a. Then we could divide it by the r minus 1 to both sides to solve for the sum. Then we have the s equals, we could factor the a out, then r to exponent n minus 1 divided by r minus 1. So this is the formula for the sum. So in this video, you have two formulas you need to memorize. We are going to use them. So t sub n is a times r to the exponent n minus 1. So this is y equals a times b to the exponent x. And another one is a sum for the n terms. So it's a times r to the exponent n, then minus 1 divided by r minus 1. All you could think is a last term times r minus first term divided by r minus 1. So another way you can memorize is tn plus 1 minus first term. N plus 1 terms minus first term, then divide by r minus 1. So they are either way, they represent the same thing. So we are going to see how we are able to use these two formulas to determine the unknown terms on the unknown sum. So determine if the following sequence is arithmetic or geometric. Arithmetic means it's a straight line, right over run. The differences are same. First difference is same. Geometric is the ratios, the base are same. So, and if it's geometric, state the general term and the recursive formula, and also determine the T7 and S7 if it is a geometric sequence. So this one we are going to see. It looks like it keeps multiplying the same number. So this is a geometric sequence. So the common ratio, or you could call the base, is 3. And the general term, it is a y equals a to the, so you could think that it's a b equals 3, and the general term is just same as an exponential function for exponential growth and the decay a times b to exponent x. And because it's a term, so we use t sub n, countable numbers for x. So a is a first term, and b we use a common ratio, and x we use n minus 1. It starts from n, so equals 1, so 1 minus 1 is 0. So that is why we change it to n minus 1. So we are going to sub in a and r. A equals 4, r equals 3 to this general term, then it is 4 times 3 to the exponent n minus 1. So you have xy left. It represents infinite dot on the graph. So that is general term. And the recursive formula, we know that for the recursive formula we need to have two parts. First one is a first term. We need the first term to start to get the next term. So first term is 4, and the next term equals the previous term. Keep multiplying the same number. This is r. And for the second one, n greater than 2, otherwise, or equal to 2. Otherwise, if we have n equals 1, you have 1 minus 1 is 0 term. We don't have 0 term. The term started at n equals 1, first term. And question C, it asks you to find the 7th term. So we just write n equals 7, sub into this general term equation to find the 7th term. So 4 times 3 to the exponent 7 minus 1. Then we are going to use calculator to find out the answer. Then use your calculator, you could find out is 4 times 3 to the exponent 6. So do the exponent first by math, don't do the multiplication. So do the 3 to the exponent first. Then we are going to have 2,916. And for the 7th term sum, we are going to use a formula. It is a times r to the exponent n minus 1 all over r minus 1. So that is a is 4, r is 3, n is 7. Take away 1, then divided by 3 minus 1. So you will use your calculator to find it out. It's 4,372. When you do the calculation, make sure divide by the denominator in bracket 3 minus 1. So this is for the sequence A. Now we are going to see the second sequence. And second sequence we are going to see is like keep minus the same number, then you could get the next term. So this one, keep adding the same number, it means the slope, the rise is -2. It is the common difference. So it's -2 over 1 because the term is 1, 2, 3. So keep adding 1 to the right. So 1 is 1. Then it is -2. And the question, this is not geometric. So the first one is geometric. And the second one, because the common difference is arithmetic. It's a linear function. So then the general term is y equals mx plus b. So it's similar with mx plus b. And here again, m is just a common difference, and x again is n minus 1. N start with 1. And the b is your corresponding is a value, the first term. So we write it out is a plus n minus 1 times d. It is similar with y equals mx plus b. So first term is 100, and leave the n there, that is the x. We need x, y there in order to have the infinite dot. They are n and t sub n corresponding to x and y. D is a common difference, is -2. So this is for the general term. And for the recursive formula, it will be two parts. The first term is 100, and after that is next term equals previous term plus same number -2, all is -2, and n need to be greater or equal to 2. So this is recursive formula. And question C, if n equals 7, we just sub in to the equation 1 here. So T7 equals 100 plus 7 minus 1 times -2. Then do the bracket is 6, the multiplication, by mice, bracket, the multiplication, the adding, subtracting. So it's 100 minus 12, give you 88. So 7th term is 88. Then the sum, the formula for the sum of the arithmetic sequence is first term plus last term divided by 2 times n. So we have the 7th term, so first term is 100, 7th term is 88, divided by 2, then times 7. We have 188 times 7, divided by 2 times 7, and the final answer is 658. So they are the two types of sequences. One is linear, keep adding the same number to get the next one. Is a straight line, but it should be scatter plot. And another one is exponential, so keep adding the same number to get the next number. But again, it should be scatter plot, not the continuous lines. That is different from the exponential function with geometric sequence and from the linear relation function from arithmetic sequence. Arithmetic sequence is dotted line, and geometric sequence is dotted curve. So that is you know these two, then you know all the needed knowledge for the geometric sequence and arithmetic sequence. After that, we just practice. So next one, example 2. Determines the number of terms in this geometric sequence. So we want to find this one is last term, is t sub n, is 1280. We know the general term formula for geometric sequence is ab to the exponent x, but because x is a countable number now, so we change it to n minus 1. And b, we use r to represent it. So r, we could get it from the next term divided by the previous term. So t2 divided by t1, negative 10 divided by 5 give us negative 2. And the a is your first term is 5. So we sub in these 3 given to this geometric sequence general term. So t sub n is 1280, and the a value first term is 5, then times r is negative 2 to the exponent n minus 1. And here be careful, you are not able to times 5 with negative 2. So negative 2 to the exponent negative 1 is one term. So we move the isolated n by moving terms to other side, moving the 5 to other side first. We do the backward of BADMAS. So we do the adding, subtracting first to other side. We don't have anything, it's multiplication. So now we do the multiplying, dividing. So we do this 5 first, then after that we do the exponent. So 1280 divided by 5 give you 256. Then equals negative 2 to the exponent n minus 1. Then we could guess and check. Negative 2 to exponent what give you 256. Guess and try, we could see is 8. And we have negative 2 to the exponent n minus 1. So we have the same base, the power equals, then the exponent will be equal. So 8 equals n minus 1. Then solve for the n is linear equation. We move the negative 1 to other side by doing opposite operation is plus 1. So n equals 9. Then we know that in this geometric sequence we have 9 terms. So that is for example 2. Then we sub in 3 given, so it's kind of we have y equals a b to the exponent x. We sub in y, we sub in a, we sub in b, then we solve for x, the exponential function like. Then after that, example 3. So for the following geometric sequence, it asks you to find a, r, t sub n, the general term formula, and after that find t sub 10 and t s sub 10. So it given 2 terms, and these 2 terms we could think that is a 2, 8, 4, 32. They are the 2 points on the graph. So this is 2 points on the graph. So 2 is 8, and 4 is 32. So you have 2 points on the graph. And it asks you to find the general term. So this is a 4. Then it is 32 here. Okay, you have 2 points on the graph. So we know that it is from this second term to the fourth term, you need to times r. So the middle one will be a times r if it's third term. Then for the fourth term, it's a times r again, r squared. So from here, you are able to see that 32 divided by 8 equals r squared. So you times r twice to get the next term. Then we could have r squared equals 4. Then we square root both sides. Remember, whenever you square root both sides, you have 2 solutions, plus or minus. So positive 2 give you squared is 4, and negative 2 give you squared is 4. So you have 2 solutions. So this one or this one. And we are going to separate these 2 cases. So case 1, we are going to see if r equals 2, then what are we going to have? So we have the a value is first term. So it's first term, it will be 8 divided by r. Then second term is r, third term is 8r, fourth term is 8r squared. So that is first term times, this is 8, okay? First term times r give you 8. So now we know that a equals the second term divided by r. We have the second term is 8, 8 divided by r is 2, 8 divided by 2 is 4, so the first term is 4. Then the t sub n is a times b to the exponent x, b is r, x is n minus 1. So we sub in a and r, then you have the general term formula. 4 times 2 to the exponent n minus 1. So this is a general formula, term formula, and after that we are going to find t sub 7 equal t sub 10 equals what? So we sub n equals 10 into this equation 1. We are going to have t10 equals 4 to the exponent, 4 times 2 to the exponent 10 minus 1. Then do the calculation, we have 2048. So that is for the t sub 10. Then s sub 10. We are going to use S sub n formula. It is a times r n to the exponent n minus 1 divided by r minus 1. Then when n equals 10, we sub n equals 10 and also ar into this equation. We are going to have S sub 10 equals a is 4, r is 2, n is 10, minus 1 divided by 2 minus 1. Then do the calculation, we have 4092. So this is for case 1. Then because we have 2 solutions, so case 2. is when the r equals -2. So you could keep multiplying -2 to get the fourth term is +32. So now we are going to find the a value is the second term divided by the ratio to get the first term is -4. And because the a and r changed, so the t sub 10, s sub 10 will change. So we are going to do the same thing as the left side, but we sub a equals -4, r equals -2 into the general term formula. T sub n equals a times r to the exponent n minus 1. So T sub n equals -4 then times -2 to the exponent n minus 1. So this one we call it equation 2. Then we just repeat all the calculations again into the equation 2 now. Then we have T sub 10 equals, first term is -4, ratio is -2, then 10 to the exponent -1. Do the calculation, you will find out it is 2048. And I sub 10, we sub in the AR and N into this formula, so we could call it equation 3. So we are going to have -4 times -2 to the exponent 10 minus 1. Then all over -2 minus 1. And this one you will have, denominator is -3, numerator is -400 and 0.92. And do the division, you will have 1364. So in this video, we have covered the two geometric sequence formula. One is for general term, T sub n equals a times r to the exponent n minus 1. And another formula is a sum of n terms. So I sub n equals a times r to the exponent n minus 1, then divide by r minus 1. So in each case, you need to find the a and r. They are the similar with a and b in the exponential function. So it's just corresponding all the x, change it to n minus 1. And the T sub n is just one term value. N's term value is corresponding to y. Thanks for watching.